All right, hello everyone. Welcome to the Friday afternoon lecture. Woohoo! Hope everyone has had a good week so far. I can see lots of discussion happening in the chat about the problem set for this week. Sounds exciting. Someone's asking, have we finished structs? No, we absolutely have not even finished structs. We will go back to structs, don't worry, but we're just going to do some loops today, because why not loop-de-loop? Okay, so today, some of the feedback from on Tuesday, from the lecture on Tuesday, was that some of you thought I was going too fast. You wanted me to slow down a little bit. So it's really hard for me to gauge, I guess, when the content is happening, whether or not I'm going too fast or I'm going too slow. So this week I created a Slido so that you can let me know throughout the whole time if I'm going too fast or too slow. And so I'll know whether to slow down or whether to speed up as well, so that we can try and get a better pace going. So Tom in the chat will now share the Slido with the number. So if you go to slido.com and then input the number 508015, then you will be able to vote throughout the whole lecture, okay? You can change your mind as you go, and I would prefer that you do that, because that will actually tell me in real time what's going on. So then I will actually know if at any stage I need to slow down an example or speed up an example without if you don't feel like doing it in the chat, then you can do it on the Slido, and we can kind of get the pace going. Okay, fantastic. So welcome to lecture 4. How exciting. We are, this is going to be almost the end of week 2. I hope everyone is still feeling confident. Everyone is still feeling, good about everything and that they can do it. Our help session was actually very popular on Wednesday, but we managed to get through it. We sent in a few extra tutors, so I hope that was helpful to those of you that came. And then next week, we're going to have 2 help sessions. One is going to be on Monday, 7 to 8 p.m. And the other one is on Wednesday, 7 to 8 p.m. And I will put that into my announcement for the week as well. So don't worry, you don't have to remember all the details. But from now on, the help sessions will be running twice a week, every week. Okay, so let's have a look. So what did we do on Tuesday? On Tuesday, we did our conditionals. We did running our code based on some sort of conditions being met. We did more complex if statements, and we kind of started to talk a little bit about the struct. So we may not touch the struct today, or we may touch it. It depends how we're going. But if we don't touch it today, we're definitely returning to it on Tuesday of next week. Don't worry, we're going to be, we're going to keep using the structs and the if statements, and everything that we're learning, we're going to use it throughout to solve problems, so that you can get a good idea of a feel for when you need to use it. So today we are doing looping. We're looping the loop. We're doing while statements. So there's a lot of problems in computer science. The if statement is very useful, but so is the while loop. You often need to do loops to actually do things, and to actually kind of be able to solve the problem. So we often need to do something more than once, and we'll talk more about what kind of problem it will solve in a second. Because I'll give you one way to solve it without, one way to solve it with. So hopefully we can get it, hopefully you'll be the master of the loop at the end of today and at the end of this week. Okay, lecture code is in the same place as Tuesday's lecture code. Please go to this link. I think Tom might pop it into the chat as well, so that you can just click on the link that Tom is about to pop into the chat. And I have chmodded all the files, so you should be able to see them. Okay, so when do we need to do a loop? When do we need to do a loop? There's quite a few times in programming and in different problem solving times that you will need to repeat something until something happens. And you might not necessarily know when that something magical is going to happen that will stop the loop. So sometimes you know how many times you need to repeat something in advance, and sometimes you don't. And there's a lot of jokes as well about while loops and programmers. And anyway, I have I did not provide any jokes. I was very good. If the other Tom was in the chat, he would be providing you with thousands of dad jokes now. Luckily for you, you've been saved. He is not. So can you think of some examples in real life where you would use a loop? So while something is happening, keep doing something else. So I said there, whilst there are songs in my playlist, keep playing the songs. So can you think of any other sort of, loops when you do things in real life, when you would have a loop going in real life as well? Counting to 10, hammering a nail, yeah, until the nail is in there, keep going. Whilst bowling, keep recording the score. If you're winning, if you're losing, you probably don't want to record the score. Love it. Password, so whilst it's incorrect, keep trying to put in the password until you get to 3, then you might stop and take a bath. I love that. While alive, just breathe. That's an excellent one. Definitely that one. Yep, that's great. While true, breathe. While parents are not home, play video games. Brush teeth. So yeah, you would have a 2-minute timer, let's say. Whilst 2 minutes is not up, keep brushing teeth, then stop. While Sasha's talking, keep listening. I applaud that. That's wonderful to see. While people eat food, chef, keep cooking. Yep. While hungry, eat. Yes. Excellent. While single, continue swiping, right? Oh, these are great examples. While mentally stable, breathe. My life is a loop. It does, in COVID, the whole day was just a loop. Everything felt like, what day of the week was it? Don't know. Every day felt the same. Now it's a bit better. You can go out and do stuff now. Walking and eating. Monotony of life. No, you're all still young. Your life should be, monotony of, programming. No one has said the monotony of programming. Whilst you're debugging, keep debugging. While dog is chasing you, keep running. It's a good idea. Unless the dog's chasing you for kisses. Then you might want to stop. While at lecture, don't fall asleep. That is one thing I really miss. I really miss seeing people in the front row start to nod off and just dropping something really loudly next to them. So I really do miss that about the live lecture. Okay, fantastic. That's really good. Those are some really, really nice examples of real while loops that we would have in real life as well. There are many of them, obviously. And, look at that. While cat's purring, keep patting. Yes, or the cat will probably hurt you. Very true. Very, very true. All right, so that's really, really nice. I think you can see, obviously, we have a lot of places in real life that we would have this type of looping situation. And a lot of times also is in the case of us actually solving problems, sometimes we'll need to do things many, many times. And even when you think about your bowling problem, so far you've only really put in some numbers for, one frame, and there's more than one frame in each game. Could it be what's coming? I think it might be. Anyway, okay, so repetitive tasks shouldn't require repetitive coding. Yep, so yeah, I can do it, like let's say for the bowling, I can do it 10 times over, but that's not really a very efficient way to code either. That's a lot of lines of code. And some of you in the chat are also talking about, other ways, other inefficiencies, things are taking many, many lines of code. And sometimes, not always obviously, but sometimes that is because, the question would be better solved with a loop. Now we are forcing you in these first few weeks, we're forcing you obviously to use the content you've learnt in week 1 and week 2. But after this, the while loop will become available to you, and you will be able to cut down some of your code as well, because you'll be able to loop something as needed. So C normally executes code in order. So it starts at your main and then it reads right down line by line by line by line. If statements allow us to turn on or off parts of our code. So if an if condition is false, we don't read the next line. We will go off after that if statement. Up until this point, we haven't had a chance to actually repeat any code. And now this while loop is going to give us this opportunity, so we're not just copying and pasting code as well. So let's see an example where it's inefficient to copy and paste code. Oh, I haven't given you one. Okay. Oh, I could just write one in code. Maybe we'll do that. Okay, well, I'll write. What do you think is an inefficient way to do some code? What about what we did on Tuesday? If you remember our dice checker exercise, can you tell me if I wanted to enter it a few times, would that be... I think Tom's answering some of the questions in chat. Okay, I'm sorry. I also have to use VS Code because gedit has had a field day. It did not want to open for me. I was on a loop just typing gedit who, gedit why, gedit what, and it wouldn't open. So, and then even from just an applications, it wouldn't open. It must be corrupted on this computer. Not on this computer, just because I'm using a virtual computer. So it must be corrupted somewhere and it's not opening for me. So I'm using VS Code again. I'm sorry. Please feel free to use gedit. Okay, so what is a piece of code that you can think of that would be something that would repeat itself over and over again, that would right now for us without a loop require us to keep asking for things over and over and just copying and pasting the same chunk of code? What do we reckon? Yeah, counting up to 100. Excellent. Count from 1 to 100. Yep. Excellent. Yep. So if let's say an example of it would be, you know, the dice, we rolled it once and then we said, okay, it meets the target, it doesn't meet the target. What if I rolled it, 10 times? How would I be able to, do it right now without having, I would just have to copy that same piece of code where I do it once, I'd have to do it 10 times over. So that's not really very efficient. You really want to be doing, a while loop here. Let's have a look at the structure of the while loop, and then we're going to write some code. Okay, so while loops can be controlled in 3 different ways. Okay, you don't have to remember the terminology for it. I don't care if you don't remember what the loops are called, the different types of things. You just have to know that there are different ways in which you can control the while loop. And sometimes some ways are more efficient than others. Usually I've seen, sometimes people will favor one particular way and they will solve their problem always from that sort of approach because they favor a particular way of thinking. That's okay as well. So they are something called a count loop, a sentinel loop, and a conditional loop. So we'll talk about them in detail. Don't worry. Okay, so 3 types of things that we can do. The way that the while loop, though, is structured is the same for all of these types of loops. You're just testing in a different way for a different type of condition kind of thing. But the loop itself and the structure of the while remains the same. So what happens is that we check this expression here. So is this true or false? If it's true, this will run in here until this is going to be false. And then when we reach this bottom bracket, we go back to check the condition again and go back to check the condition again and go back and check again and again and again. So the while loop always works in such a way as that whenever this expression is true, whatever's happening in that bracket is true, we're going to keep doing whatever's inside the curly brackets. So the way that it works in code is that you have to do 3 steps. 3 steps in particular to be able to use a while loop efficiently. So first of all, you will need to have a loop control variable. Again, you don't need to remember the names for all of these things. You just need to know what you actually need to do. So the loop control variable is some sort of variable that we use in our while loop to check whether our expression is true or false. So we check against that loop control variable, and if something is true, we'll go inside here. And usually the last thing that we do inside our while loop before we close our curly bracket is that we update that loop control variable. So for example, if we're using a count loop, okay, so if we're using a loop that counts, and we know how many times, we need to do something. So we want to do this 3 times exactly. So we need to keep updating that count so that it's able to actually reach 3, because otherwise what you're going to do is you're going to create an infinite loop. Now, who's heard of the term infinite loop? Oh, Tom's raising his hand. This is good. Someone's listening. Who's heard of an infinite loop? A few people have. An infinite loop is super duper fun. You will encounter quite a few of them. I remember last term I got a bit worried that I'll crash my machine, because my machine at home was so slow, and it was during the lockdown. And I was running a few things, and I only did the infinite loop right at the end of the lecture, because in fact it did crash. It crashed everything. So how would we create an infinite loop? Should we create an infinite loop just for fun? Let's see a while loop that is going to be an infinite event. I'm going to do it in here. So first of all, let's see an infinite loop. No. Oh. I'm here. Sorry. I had it on the pen, but I was trying to use the keyboard. Okay, let's, or not. Yes, we're back. Okay, so first of all, let's include our hash stdio.h. People are saying yes, or whilst something is true, then we keep doing. Whilst 1, I feel like people have done this before. Excellent. Okay, let's... I love it. Okay, so let's do an int main, and we'll do a void inside here. Open curly bracket, close curly bracket. I'm going to return here. Okay, I'm going to create an infinite loop for you for fun, because I'm assuming that this computer will not crash. I hope that this is a safe assumption. But if it crashes, I'll see you in a few minutes as I reboot. Okay, so we'll do a while loop. Now people are saying, someone had a really good one, 1 is equal to 1. So this condition here, 1 is equal to 1, that's always going to be true, right? It's never not going to be true. So what that means is that it's going to keep going and going and going and going. I'm going to do something simple. I'm going to print out something whilst something is true. So I'm going to print out it is an infinite loop. Oh wow, I'm just so creative. It just amazing. Okay, let's save it and then let's run it. Okay, DCC. Oh gosh. Okay, and you see it's letting me really continue. Oh, to infinity and beyond. I do. Yes, I should have done that. Too late now. I should have done to infinity and beyond. Also infinite is just a really awkward thing to spell. Should be the next Wordle. All right, so what happens now? Now, if you probably it just looks like it's kind of sitting there, but it's not sitting there. You can see that my scroll bar is getting smaller and smaller and smaller and smaller, because it's filling up the screen with just something that says it's an infinite loop, it's an infinite loop, it's an infinite loop, it's an infinite loop, and so on and so forth. So there is not going to be a way of stopping it. At some stage, it's going to be like, no, that's enough now. Thanks a lot. And so someone I can see in the chat has said how we can stop it, where sometimes you will do this in your code. Absolutely 100% at some stage you're going to create an infinite loop. It does happen. So to break out of these loops that never stop, or to break out of something that's not working, you press Control-C to stop the program, okay? This is going to become your friend as you keep doing your assignments. Control-C, because it's very easy to create these types of situations. So I'm going to Control-C, and it's going to exit out for me, which is very nice. And if I scroll up, you can see that there is just a lot of this to the point where it swallowed up anything that happened above it, okay? So don't forget to break out of this terrible situation that you might find yourself in quite often. Control plus C, okay? So Tom, if you can pop it in the chat, Control plus C is something that will become your best friend. It is a way for us to break out of these tricky situations that we do not like, or if you've created an infinite loop, it's a way for you to break out of it. Okay, so let's have a look. Yeah, so someone just closed the terminal. True, you can just close the terminal, but it's much faster to just press Control C. Although sometimes it's a bin on fire and you just wanna buy, done. So there we go. All right, so that was a lovely infinite loop, and there's obviously a few ways to do it. I could have said if 1 is less than 2, then you print something out and it never stops. It's just a never-ending loop. Okay, so let's talk about count loops to start with, because count loops are probably, I don't know, no, they probably make, no, they make as much sense as every other loop. Just loops, they make sense. Maybe, we'll see. I think the sentinel loop probably makes the least amount of sense because you probably haven't really seen something with a sentinel before. So if we have our count loop, what that means is that we know how many times something is going to happen, and what we're going to do is we're going to do it that specific number of times. So each time our loop is going to run, we're going to update that count and we're going to proceed down to see what's going on and whether it's true or not. So for example, if you have this little piece of code here, you notice here the first step, always in a while loop, we declare and initialize a loop control variable just outside the loop. So it's done just outside your while loop. And so here I've called this variable count, which is just, again, just killer variable names. All right, because I'm counting, okay? So I'm doing count, I've set it to 0. So I've initialized it to be at 0. Will you always have something initialized at 0? Not necessarily. You might have a different count. It depends what your programming question is. It depends what your solution will be. Maybe you want to start at 1. Maybe you want to start at 0. It depends how you're counting and what you're doing. In computer science, usually very good practice to start at 0, but there are problems where you would start at a different number. Okay, because I have started at 0, if I want to count to 5, I'm not going to include 5, as you notice here. It's just going to be whilst the count is less than 5. And the reason that it's just less than and not less than and equal to is because I've started counting at 0. So I'm going to have 0, I'm going to have 1, 2, 3, 4, and I'm going to stop. I'm not going to make it equal to 5 because that means I've actually gone around the loop 5 times. So if I'm starting at 0, it will not be equal to as well if I'm counting to a certain number. But if I had started at 1, then I would want it to be equal to 5 as well. So inside your brackets with the while statement, you test the loop control variable. So this is what I'm doing. I'm testing it against my counter that I'm keeping track of here. I'm saying, is it less than 5? Okay, great. Then I'm going to print something out, or I'm going to do whatever it is that I want to do in my while loop. And then for the third part of this whole equation, oh no, it's gone off. It's gone off. Okay, there's something wrong. There's something wrong in this count loop. And what is it? Exactly. Yes, this is what happens when I get so excited. What I've created here is another infinite loop. Okay. Can anyone see why this will be an infinite loop? See, I was so excited. I was like, it's time for some Messina. Yes, it is. This was the moment I ordered Messina, and then I moved on from this lecture. So apologies. Yes, well done. Someone's got it. I'm not incrementing. I'm not doing part 3. So part 3 happens at this point in time over here. It happens just before I close my loop, and I need to actually update my loop counter or my loop control. How am I controlling my loop? So what I need to be doing is I need to say count is equal to count plus 1. So I've increased it by 1, so that means that I can go up by 1. Yeah, so I've created an absolute an infinite loop by accident. And lots of people seem to know to do count plus plus. So I have done still count is equal to count plus 1. Now, for those of you that don't know and are seeing it in the chat, it's the same thing as doing count plus plus. It's like a shorthand way of doing things, okay? So this over here is the same as this over here. Okay, my goodness, excellent. Yeah, I hope that this question would mean I always get to have ice cream. I love ice cream. Okay, that was a tangent. Sorry, didn't mean to go off on a tangent about ice cream nonetheless. And then of course I do a question with ice cream as well. Okay, here we go. Let's go through this and then we'll do a little bit of a code for our count loop. And we will do some of the shorthand ways of doing things. We're going to do that in Tuesday's lecture when we talk a little bit more about style. We're going to do, and someone's asked a great question. I can see it in the chat. What's the difference between count plus plus and plus plus count? I'm going to talk about it next week. Okay, one is a pre-increment and one is a post-increment, and it's a really great question. There is a difference between them, and we will talk about it. Okay, I'll leave Tom now to answer the questions in the chat unless they go on the board. Okay, so let's look at this code over here. All right, so what have I done here? I've got some scoops. I've got my sum of scoops. And the first thing I do is over here, okay? I start out by declaring and initializing a loop control variable, okay? I'm going to call it int count again, and I'm going to make it equal to 0. So again, I'm starting counting at 0, and things are going well. Nothing has happened yet, so obviously things are going well. I haven't stuffed it up yet. I haven't created infinite loops. Things are going great. Then the second thing I'll do is I'll test the loop control variable against the counter. So let's say I'm counting until 5. So again, I'm going to check that the count is less than 5. And then I'm going to say, okay, how many scoops of ice cream have you had? I'm going to scan in a number for the scoops. I'm going to add it to the sum. And then I'm going to print out the answer. And then the magical thing that I forgot to do last time up here is that I need to update my loop control variable. So I need to change it up so that I'm able to see, I'm able to increase it up by 1 so I don't create an infinite loop, okay? Okay, so let's go to our code because I think this will also make a lot more sense once we start coding as well. Wait, where is my... Here it is. Oh, it's not going to be that nice. Let me erase all of this. Okay. I'm going to write some code. Not like that. Okay, here we go. So I would like to demonstrate the use of a while loop with a condition. And let's look at it using our dice problem again. So I want to read in the scores until the final total score is less. No, this is the wrong loop. I should be on the counter. I'm sorry. Let me move this across. Okay, while loop with a counter, right? That's the one I'm doing. Okay, I want to roll 5 times and compare the total of all the rolls to the target number. So before, when we did this question on Tuesday, and let me open it up for you so that you don't forget it, dice checker.c. Okay, so before this, when we did this question, our target was 9. We rolled it once, we took it in, and then that was it. You know, we just said, okay, the sum is less than, the sum is more than, or the sum is equal to target. So now we want to do it 5 times over. And then we're going to say, is the sum, you know, is the sum close to the target or not? Okay, let's do that. All right. So probably in another week, I will stop doing things from scratch because I will assume that you can follow me along. But for now, I'm going to keep doing things from scratch so that you can see how to structure the program as well. Okay, so hash include the standard input output, and then we're going to start our program. Int main void, open the curly brackets and close the curly brackets. Okay, so we have our basic structure for it now. So what are we trying to do? What is our problem trying to do? Okay, we're trying to do a few things in our dice problem. So the dice problem basically said, and we want to roll dice 5 times. So roll dice 5 times. Scan in input. Add to total. After 5 times, compare total to target number. Okay, so we've got a few things to go on. Okay, well, we want to have a target number, I guess. Okay, so let's do our target. Now, remember, we're going to be rolling 5 times. So give me a target number that will be big enough to kind of accommodate that. Who wants to give me a big enough target to accommodate that? $20, $30, yeah. Okay, let's do 20. Let's do it. Okay, yep. Excellent, very good. Oh, 205. You'd be hard pressed to get to that in 5 rolls. But that's a nice one. That would never get that. Okay, so let's do that. So what we're going to do now is we're going to be able to go through it and scan in some numbers. So what should we do first if we want to do something 5 times? I'm going to copy and paste some of this code into, so we're not just rewriting code. This was the code from Tuesday. So I'm going to paste it in here so we can work with it already. Okay, so right now, what are we doing? We've got 2 dice, we've got a sum, we're checking the scanf return, and then we're printing out enter the dice rolls, we're scanning them in, and then we're going to add them up, and then we come up with something or other. Okay, so now instead of that, what we want to be doing, we want to have a total of all the rolls. So we want to keep adding to the rolls. So every time, keep adding, keep adding, keep adding. Okay, so what do you reckon? What have we just learned? How do you do something more than once? I mean, I could then printf, copy this code and paste it down here to do it again, but that's not really an ideal way to do it, is it? Not really very efficient if you copy and paste this, 5 times. So what can we do? How can we do it 5 times? What do you reckon? Yeah. We can do while count is less than 5. I agree. And because 5 is not changing, okay, 5 is going to be constant, I'm going to hash define the 5, okay? So I'm going to say my 5 is the loop, and it's going to be equal to 5. Okay, and let's now do our while loop. And whilst, and what do we need if we're comparing it? So remember, in the while loop, we'll have 3 different things we have to do. So first of all, outside of the while loop, we need to initialize our loop control. So this is what I'm going to do. I'm going to call it a counter, and I'm going to make it equal to 0 to start my counting. Yep, so in count is equal to 0. Excellent. Then inside my while loop, what I'll do is I need to test the loop control variable. In our case, we have a condition. The condition is we want it to be less than 5. So I'm going to test it by saying whilst count is less than 5. Yeah, that's right. Yeah, I'm with it. I'm with it. That's the less than symbol. Excellent. Okay, so while that's happening, I also want some curly brackets here. and then let's see what we need in here. Okay, so whilst that's happening, we want to ask for some die rolls and we want to do all of this stuff. So I'll cut that out. I'll pop that inside here. Okay, so that means inside the loop, we're going to print out, enter the dice roll, 2 numbers, scan whatever those 2 die rolls are. Okay, then we're going to check that 2 things were scanned in. No one entered a letter or something. Okay, and what do we want to do then, do you reckon? We want to add them to the sum, don't we? Okay, so I'm going to cut this. I think someone's asking for a bigger font. God. I'm not going to be able to fit much on the screen. That's the only issue. Let me try to go bigger. How's this? You can't see much of anything, but let me try and give more space. Okay, how's that? So someone said, is there any reason I used a hash define instead of just saying less than 5? So because I'm not changing the 5 is a constant, I used a hash define instead for it, because better style to use those types of hash defines when something is not a variable, when it's not changing, which is why I used a hash define for it. Okay, so we're going to add our die 1 and die 2, but what should we be doing? And this is why on Tuesday, it's good practice also to just say that sum is equal to 0 at the very start over here, which is what I've done. Because I want to be adding the 2 die numbers, I want to be adding them to the prior sum each time I go through the loop. And we're going to walk through it. Jack, I used Dice Checker from last week. Let me save this and then you can access it on our website. Okay, saved. Okay, so now what I'm doing is I'm taking the sum, I'm adding the old sum from before, and then I'm on the maximum possible width of the window. I have no more window left, which is why this is the maximum possible that you can do, which is why I've done it. And I know someone wanted to see, you know what I'm going to try? Maybe I'll do tiny little terminal and I'll do a lot of this. And then what I'll do is I'll lower my terminal down and I'll put it down the bottom. What do we think of that? How's that? Does that feel better? Okay, let me know if that's better or if to go back. Yeah, I've done Control Plus. This is, you can see Control Plus. Okay, better. Good. Now people want me to Control minus. My goodness. Okay, I'll go 1 Control minus. Too small? Too big? Just perfect. Can I scroll up? I can indeed. Okay, so what do we got? We've got a place outside of our while loop that is initializing the control. And that control is called count, and I've set it to be equal to 0. It is usually convention to start counting at 0 in computing, okay? But that doesn't necessarily mean that you have to each time. Certain problems will better benefit from starting to count from something else, okay? But usually, not in all cases, but usually you will start counting at 0. Okay, then the second thing I'll do is I'll compare whether my count is less than the loop, because I want to go around 5 times, okay? I'll print out, enter the 2 dice, and then what I'll do is I'll ask for some, to take something in from the terminal, and then I'll add it all to my sum because I want to know what the total is. Okay, then someone in there, perfect, has pointed out, actually, we need number 3 as well. We need to update our loop control. And the way you do that is you do it right at the end of your while loop. I usually like to think of it as the last thing I do before I come out and close that while loop, okay? Okay, so I'm going to update it. So count, I'm going to use plus plus, or would you like, if you prefer, I can use count is equal to count plus 1 for now. I might just do the long way, the long way for now. So I've updated my loop control. I'm ready to go again. It's going to increase. So what will happen if we look at this, let me go through it with a pen so you can see how it all comes together. Okay. Okay, I started counting here at 0. So count is currently 0. Here I'm checking, is 0 less than 5? Is 0 less than 5? Yes, it is. Fantastic. That means I enter inside the while loop. I'm going to print out enter the dice rolls. I'm going to take in two numbers, whatever those numbers are. Let's say they're 3 and 2 are the two numbers that I'll scan in. Here I'll say sum is equal to, now this is why we used that in sum is equal to 0 at the very beginning. Because if I didn't have, when I initialize my variable at the very top, sum is equal to 0, what will happen is it will have sum here, and then it will try and access what is this equal to. And if this doesn't have a value, you'll get an error, a compile error, and you will not be able to go on with your code. Because the first time you access this variable, you need to have some sort of value to it. So for me, it's 0, and then I've said my values are 3 and 2, so I'll add them up. Great. So that means my sum is now equal to 5. Okay, and then I'll increase my count. So my count was 0 before, and now it's going to be count is equal to 0 plus 1. So the new count is equal to 1. So my count is now 1. And then I'll return to my while loop again. And now I'll check, is 1 less than 5? Yes, it is. Great. Then I'm going to enter inside the while loop. I'm going to do all of this again. Let's say I'm just going to put in 3 and 2 again. My sum is now 5. So when I do this down here, what will happen is I'll have sum is equal to 5 plus 3 plus 2. So the new sum will be 10. And then I'll go down here. My count is now 1, so it'll be 1 plus 1, which is 2. So the new count is 2. I'll go back to the while loop and I'll check again. So I'll do is 2 less than 5? Yes, it is. So then I'll go in and do it again and again until when I check in here, it's going to be false, which is going to happen when it's equal to 5. So when 5 is less than 5, that will say, no, that's not true. That's not going to be correct. And that means I'm not going to go inside this while loop, and I'm finally going to come out of the while loop. Okay. All right, so we've updated the loop control, and now the only thing that's left for us to do is compare the sum to the target number. And we have our target, so if the sum is less than target, we'll say that the sum of the dice is greater. If it's less than, we'll say it's less than, and then if it's perfect, we'll say that you've guessed the target number. So let's see what happens when we run it. Okay, let's run it. I forgot what it's called. While counter. Now you can't see what I'm typing. Let me do that. Okay, there we go. Okay, let's see what it's got for us. Okay, compiles perfectly. Great. I like it. So let's now do run it. So /while counter. The first thing, let's do 2 and 3. And then we'll do, and remember the scanf is there just for nothing in particular. It's there to check for errors. 1 and 2 and 1 and 3. Okay, so let's check that it did it 5 times. Let's have a look. So 1, 2, 3, 4, 5. So it went around the loop to ask me for 5 times to enter in my numbers, and then it added them all together and it said, is it greater than or less than? So if we count them up, oh God, this is really going to strain me on a Friday afternoon. 2 plus 3 is 5, 5 plus 5 is 10, 14, 16, 19, 20, 22, 25, 26, and our target number was 20. So it should say that we're greater than the target number, which we are. Okay, so fantastic. It's doing what we wanted to do. Okay, someone has asked why we need that sum in there. Okay, that's a very good question. Okay, so why do we need that sum in there? The reason for that is because I want to be able, if I don't have it, okay, it's easier to go if I don't have it. What's going to happen is that sum, each time you go through that loop, is going to be overwritten by the new value. So for example, if we had to go through it without it there, let me draw it out. Again, we've got our count is equal to 0, and my count is equal to 0. I'll start counting 0 here, and I'll write sum here. Okay, so my count is equal to 0. I'll say is 0. There is a button on this pen that I keep pressing. I'm sorry, that's why it keeps lighting up with weird things. Okay, is 0 less than 5? Yes, it is. So I'm going to go inside here. I'm going to enter two numbers, and let's say I enter 3 and 2. I've scanned them in. So now I go down here and I say sum is equal to die1 plus die2. So 3 plus 2. So sum is equal to 5 over here. And then I'll say count is equal to count plus 1. So that's where it's going to be 0 plus 1. So count is now going to be equal to 1. Excellent. So then I'll go back down to my while loop, or back up actually. Okay, that's now done. I'll say is 1 less than 5? Yes, it is. Fantastic. So that means I'm going to go back inside the while loop. And let's say now I'm going to enter the numbers 1 and 2. Okay, I'm going to come down here, and now I'm going to say sum is equal to 1 plus 2. So the new sum is actually going to be equal to 3 now. It's no longer 5. I've overwritten that 5. So what happens is I'm not keeping track of what it was before. I'm just overwriting it each time with whatever that final roll was. So when I come out of this while loop, when I do my 5 goes, what I finish up with is whatever the sum is of the 5th roll. So whatever it was when it's up here, whatever the two numbers are added up to, that's what it will be, as opposed to the sum of all the rolls that I've done. And so that's why when we're writing it like this and we want the total sum of all things, we also adding the sum to it, because that means that we're keeping track of the last sum that it was and adding it to the new numbers. So that means that what you're getting is you're getting a whole bunch, you know, of things that add on, add on, add on, add on. So that's why you have the sum is equal to sum plus whatever is going on. And that's part of the reason that you then also do sum is equal to 0. Okay. It's a real mixed bag. I can see there's most of you are saying the pace is just right. A few are saying it's too slow, and the same amount are saying it's too fast. I'm going to go with whatever the happy consensus is, and the majority are saying just right. So I'm going to try and go at this pace for now. And once it switches over, I'll change the pace as well. Okay, so that's kind of the basic of our condition. Okay. Now is a good time. It's 3:55, so maybe a good time to take a 5-minute break before we go on to the next while loop as well. Okay, so let's take, did I prepare a little riddle? I've written all over the screen as well. Oh, do I have a riddle? I do have a riddle. How exciting. All right, let's have a 5-minute break. We'll be back at 4 o'clock. we're back. How exciting. Hope you enjoyed a little stretch. Love the answers. Some very, very creative answers there. Some of them come from like old Google interviews and old other tech company interviews, because they like to sometimes have these left field sort of things. Anyway, so some of them are buzzing about the internet. Some of them I take out of books because I love riddles. I think that they're, I don't know, fun. And they kind of, you know, they help you to learn how to problem solve outside the box. I mean, you'll hear that a lot whilst you're at uni, I think. Just think outside the box. All right, so right now at the halfway mark, the pacing is 52% are saying just right, 27% saying too slow, and 21% saying too fast. So going with the happy majority, it's just shifted in real time. Okay, 53, shifted again. I can't keep up. There's a lot of shifting going on now. Okay, keep letting me know what's going on. We'll, anyway, keep updating it as we go so that I know if I'm starting to go too fast, if I'm waffling, and so on and so forth. And someone's saying, what's the answer? Oh, what's the answer? 50 motorbikes, each has a petrol tank holding enough petrol to go 100 kilometers. They can still all only go 100 kilometers. So because they still, the 50 motorbikes, unless they're riding on top of each other, and saving petrol and doing a relay race, that could be interesting. Is that even possible? Not really. But I mean, think outside the box. Why not? Okay, so that was a while loop with a counter. Okay, let's do a while loop now that does not have a counter. Let's do a while loop with a sentinel value. Who knows what a sentinel value is? Who has heard the term sentinel value? I feel like until I started programming, I'd never heard of the term sentinel value. I didn't know what it meant, and I felt like it was a really confusing, be a great wordle actually. Too many letters. But other than that, it would be good. Okay, so who's heard the term sentinel? It does stop the loop. It can stop the loop depending. Yep, okay, so a few people have. Yes, someone has done the perfect comparison. It is like a flag. Okay, so basically it is a value that you use. You decide what on earth is going to be the start and stop based on that value, and you use it as a flag to say if something has happened or if something has not happened. Okay, so what happens if you don't know the number of repetitions? Because when you use a counter, you know exactly, I need to do this 5 times, or I need to do this 10 times, I need to do this 1,000 times, and you can just count along until you reach that number. But often you don't really get these perfect problems. Someone's got a red flag. Maybe that's how you'll feel about it afterwards. I don't know. So basically, yeah, it's like when something is true, do this. And when something is false, stop doing that while loop. So the sentinel value is kind of like a flag value. It tells the loop when it can stop. So for example, you can keep scanning in numbers until an odd number is encountered. And when you have an odd number, then you can switch off your sentinel. So you can switch it to a different value and you can check for it and say, okay, well, this is now like false. So that means I don't do things anymore. So if we keep scanning in numbers until an odd number is encountered, we don't actually know how many numbers we'll have to scan. And we know that the only time we can stop is when we see an odd number. So that will be when we get the flag and we can say stop, no more. So that is your sentinel value. And there are times when sentinel values are more useful to use, but more efficient to use. Often you can do things in different ways. So in computing, we can solve problems in many different ways. And even out in industry, I've seen the same problem solved, 20 different ways. And a lot of it also has to do with how we think as a coder, and how we solve problems. So you'll get very different solutions across for the same problem as well. So we can use a variable to decide to exit a loop at any one time, and we call this variable a sentinel, and it's an on-off switch basically for the loop. It's a flag that you use to say, okay, something has happened, so now we are on or off, and that means that we can keep going with the loop or we can stop with the loop. So let's see an example. Okay. I really overcommitted to the ice cream example. Apologies in advance. I feel like week 10, it's just ice cream time. Okay, so let's talk about it again. So this is kind of like a very similar piece of code that I had for the count loop. And even here, my goodness, I forgot to change this. This should say sentinel loop. There we go. It hasn't changed it on the slide. I'll update the slide. So what happens is that we are going to control the loop with a flag. Okay. What we're going to do is we're going to have a flag here. So number one, and you see the same thing. Every while loop, even though you're using different things to control them, it doesn't matter. The loop itself is very similar. You always have the same things happening in the loop and the same things that you need to do to make this loop do what you want to do. So first thing first, we declare and initialize a loop control variable. So we say how on earth we're going to do. Oh, it's because I made another mistake. You see, good pickups. That should be a scanf. Well done. So first of all, declare initialize a loop control just outside the loop. I'm going to make a flag and I'm going to call it end loop. Again, creative. And I'm going to make it equal to 0. So I'm going to use it like a 0 is I do something whilst it's 0 and then I stop when it's 1. And it's up to you to decide what are the values that you go, that you stop. Okay. So often, again, based on how you think and based on what makes sense to you, you might use the opposite way. So 1 is true and that's when you keep going. 0 is false and that's when you stop. So up to you to decide which way you go. Okay, so I'm going to then do number 2, test the loop control variable. So I'm going to check whilst this condition is true. So remember, I've set it to this condition here. I'm checking that it's still true. Okay, I'm going to print out, please enter the number of scoops. I'm going to scan F. That should be an F. Apologies, I'll fix it. And then I'm going to say, okay, if it's greater than or equal to 0, I'm going to sum it and I'm going to add it to the number of scoops I have. Or if it's less than 0, what I'm going to do is I'm going to update the loop control. So I'm going to say, this is my flag. Someone's entered in a negative number. I'm going to stop scanning now. And so what I'm going to do is I'm going to set this to 1. So then when it goes back up to the while loop, this end loop is now equal to 1. And this condition is now going to be false, which means that you can come out of the while loop and you no longer have to do, that you no longer have to do it. Okay, let's see it in action. Let's do a sentinel loop. I do feel like I'm some sort of, I don't know. Whenever I say sentinel, it just, I don't know, it feels like I'm saying, I don't know, something else. It's weird, just, I wonder what the background is of the word itself. Just weird tasks. Trivia. Okay, let's have a look. Let's go to while sentinel and let's have a look here. Okay. Demonstrating the use of a while loop with a sentinel condition. Okay, let's do this. I want to read in some scores until a negative number has been entered and I want to only sum together the odd scores. My goodness, so much happening. So let's do that and let's do it from scratch. So exciting. All right, so once again, let's do our hash include stdio.h and then let's do our int main void curly brackets 10 0. Okay, so we've set ourselves up. I'm going to say, all right, the first thing I'm going to do is initialize the loop control or my sentinel. and I'm going to call it end loop flag. I don't know. I really struggle with variable names sometimes. Okay, end loop flag, I'm going to make it equal to 0. All right, so what are we doing? We're going to scan in some scores until a negative number has been entered. Okay, so what do I need to be doing? I need to be keeping track of my scores. So I'm going to be scanning something and I'm going to score it, and I'm going to sum the scores together as well. So I need something to store my sums in there. Okay, excellent. Let's have a look. Okay, so I've got now a score to store some scores, and I've got a sum that will score all my scores added together, and I've got a sentinel value that's going to be equal to 0. Okay, great. We've set the loop control. It's time to do the loop. So while some sort of expression in here, okay, it shouldn't say expression. I'm just going to wait for you to see if you can tell me what should go inside my expression. I like that, to observe. So here we should be testing the loop control. So how will we test it? What will we write in there? Yep. So is my end loop flag is equal to 0. So what I'm doing is I'm basically checking that it's equal to this first thing that I've set it. And when my condition is met, and what's my condition? Condition here, until a negative number has been entered. So if this is my sentinel here, I want to switch the flag to different position when negative number red. Okay, that's the only time I want to switch my sentinel on or off. Lots of people are asking about breaking out of loops. I'm going to let Tom answer it. It is very bad practice to break out of loops. I'll just quickly comment on it because I think it's important, but Tom will also answer it in the chat, and maybe Tammy as well. But the reason it's really bad, so we use breaking a lot when we're debugging code, and that's so that we can exit the loop when we want to exit it to see what values it has. But if you're using a break to control your loop, that's quite unpredictable in code, and it's very bad style and very bad coding practice as well if you need to use a break to control your loop. There's very little need ever to use a break in that way. So a break is great for debugging code because it allows you to see what things are at certain points, but definitely not to finish out of a loop instead. So you don't want to be using breaks. It's called, it's lazy coding, and you can at some point lose control of what you're doing and of your variables when you break out. There's a lot of unknown possibilities and actions that can happen based on that, which is why we don't really want to use breaks. Okay, so we've got our loop, we've got our sentinel. We want to switch it when it comes to when negative number's red. Now in here, it also says we only want to sum together the odd scores. So I'm just going to note that down here so we don't forget. Sum together the odd scores only. Okay, fantastic. So we've got our flag. Great. Now we want to be able to enter a score. So let's prompt the user for a score. And actually one of the tutors told me that, I might comment on it in the lecture, what a great time. One of the tutors told me that a lot of students think that a scanf goes together with a printf. They go together. They are like, always together. That is incorrect. They're cousins. They're not, they're not dependent on each other. What it means is that you can use a scanf without a printf, and you can use a printf without a scanf. Okay. The reason that we use the printf, it's actually just good usability. I think some of you had an exercise in your lab that didn't have the printf prompt to start with, and it was really confusing because you run this program, nothing's happening, you forget that you actually just need to put in whatever it is that you need to put in. So that's the only reason that we do that prompt. It's very good usability. It's good practice to, if you want the user to input something into the screen, then you will actually ask them for that input as well. So please enter a score to add to the sum. let's say, why not? And then we're going to scanf something in, and we're going to scan in that score. It's going to be an int, and it's going to go inside my variable score. Excellent. Okay, now we have a score. Okay, in this case right now, I'm not going to error check because we're going to error check again on Tuesday. So I'm just going to leave the error checking. But if you want after the lecture, feel free to play around with some error checking as well. Okay, what is important to us? We need to know, because the flag, the sentinel flag, is going to switch if we've read in a negative number. So here we really need to know, is the number that we have read positive or negative? Just ignore any spelling mistakes I make, please. Okay, so is the number that we have read in positive or negative? So I'm asking a question. It needs a decision. So I'm going to use an if loop. So if the score is greater than or equal to 0, yeah, then that means that it's not negative. That means that that's where all the action happens, basically. That's when I sum it up. But I only have to sum it together if it's an odd score. So my goodness, I think I'm going to need to do another if statement, okay? So first of all, I've checked that it's greater or equal to 0. And now I need to check, is it an odd number? So I know whether to add it or not. How would we check that something is an odd number? How would I check that score is an odd number? Divide by 2, I like it, yes, definitely, but exactly, modulus. So I would use modulus 2. So if score modulus 2 is equal to 1, that means when you divide by 2, your remainder is going to be 1, and that means by definition you are in fact odd, okay? So if it's equal to 1, or if you wanted to, you could say that it's not equal to 0, yeah? So that means that you're not even. Up to you. Again, you will get a feel for how you want to solve problems, what is most intuitive to you as well. So definitely there's two possibilities here. I could also say here that score modulus 2 is equal to 1. That is also okay to do. Okay, so I've missed opening a curly. Let me close this curly. Won't let me. It hates me. Now VS Code hates me as well. I'm going to have nothing left to use here. Okay. So if it is correct, and if it's odd, then what I want to be doing is I want to be adding it to my sum. Okay, so sum. And you'll notice that I'm going to use a very similar way to add it the way I used in the last example, so that I can keep adding these numbers on. Okay, so sum is equal to sum plus score. And again, that's the reason that we made sum is equal to 0 here. So the first time you do this, this variable over here has a value. Okay, so we've added it onto the sum. So should we keep track of what it's doing? Let's just, for our sake, let's just keep track of what it's doing so that I don't have to add a whole bunch of numbers at the end, okay? So I'm just going to pop out, not the sum is now %d, and I'm going to close that, and I'm going to print out the sum. So it keeps up with the sum, whatever's happening. Okay, great. So great, that's our if statement here. Now, what happens if the number is negative? What do we want to do if the number is negative? So if the number is negative, that's when we want to switch our sentinel flag. So that's when I'm going to make this end loop flag is equal to 1. Okay, so it was equal to 0 before, and I've said if the score is greater than or equal to 0, fantastic, I'm going to do something with it. Otherwise, that means the number's negative, and I'm going to make it equal to 1. Okay, so we've made it equal to 1, And that means that when it goes back to the start of the while loop to check the expression, it's going to be false and it's going to finish up. So then at the end here, just to make sure everything's okay, we're going to print out the total, the final sum of the whole thing. All right, excellent. All right, let's run it. Let's run it. I've got a mistake. I do have a mistake. Who's picked my mistake? Has someone picked it? Yes, a few people have picked it. Well done. Oh, I'm so happy. Why two? Because I'm not concentrating. I'm concentrating on something else, talking and writing at the same time. It should be 1. Well done. Excellent. Because I'm not checking for equivalency. I'm assigning a value. Okay, and because I'm assigning a value, it should have just 1 equal sign. So well done, great spotting. Glad to see everyone's on the ball. Everyone's awake, fantastic. All right, let me compile this and run it. Oh, I forgot the .c. Don't worry about it. I'm with it. Here we go. Yes. All right, let's do it. Okay, let's do score 3. Let's do score 4. And look at this, it didn't do anything for 4. Why didn't it do anything for 4? Because 4 is an even number. If I do 6, it does nothing. If I do 8, it does nothing. If I do 9, it's an odd number, it will add it up. If I do 3 again, odd number, it will add it up. If I do 1, which is a good number to check because it's right on the edges there, it adds it up. If I do 0, nothing. If I do 10, nothing. And what happens when I do -1? It finishes everything up and it gives me the final sum of all the scores. Okay, so that's an example of using a flag to start and stop and to basically have 2 different conditions that you can switch on and switch off based on whatever your needs are. Okay, it's not, they're not like super defined or anything like that. I've just realized I'm in the way of this camera. It's not working on the other side. Oh yeah, it is. There we go. So you now have a way to end with a flag as well. Okay, and last of all, but not least, you have another loop with a condition. What that means is that you have a conditional loop. And you use a condition to exit the loop at any time. And actually, our last example could have been also done with a conditional loop as well. And this is what I mean. There's always more than one way to solve things. There's no one perfect way. Well, maybe there's one. No, there's maybe more optimal solutions than others, but there's many different solutions to each of the problems as well. Okay, so conditional looping means that we also do not know how many times we may need to repeat something, but we will terminate as a result of some type of calculation or of something happening. Okay, so what that means is that we'll declare and initialize the whole thing. Okay, and we'll do, okay, let's say I'm going to use sum as my control. So I'm going to check against the sum. When the sum gets close to 100 or more than 100, I want to stop. Okay, so I'm going to use that as my control. So what that means is, and again, look at this, see, that shouldn't be count, that should be condition loop. I'll have to fix it, sorry. That should be condition loop. Okay, so again, so I'm using this as my condition that I will check against. Okay, so what we want, we're going to set it to 0 to start off again, and then when I test my condition, I'm going to test that it's less than 100. And when I test that it's less than 100, that means I want to do all of this stuff. Okay, so then I'll enter in some more scoops. I'll add the scoops. I'll eat the scoops. I'll add it to my sum. So this is where I'm updating the control variable, the control condition, and then I'm going to check again. And when I get to 100, perhaps that's too much ice cream for anyone, and I'm either going to vomit or I'm just going to have to stop eating ice cream. But that means I'm going to exit out of my while loop and go on my happy way. But again, see, it doesn't matter which type of while loop you're using. It doesn't matter because every step is always the same. You declare something outside of the while loop that you're using to control it. Inside the expression, you test it. And then at the end, you update the loop control. Okay. Let's see it as an example, shall we? And then we'll do something, again, a harder one. A while inside a while. Okay, let's do this one quickly. Condition. Okay, that's the one that I was just playing with, so I'm just going to delete this where I created the infinite loop. I'm using the dice problem again, so I'm going to copy it out of the counter. But this time we want to stop, okay? So this time we want to stop when the total score is less than 100. Good God. I don't like this question. No, I'm going to do a different question. This one is too hard, basket. No. Let's do, what's going to be our condition? Who can think of a fun condition? It's probably not the ideal thing to do either. But who can think of a really fun condition to stop with? Oh, someone wants Pringles. Once you pop, you can't stop. Better be careful. Until X amount of ice cream is consumed. Oh, I love it. Okay, let's do that. All right. How much ice cream should we consume? Oh, someone's saying until 2,000. My goodness, I wouldn't fit on the screen. Until I eat 6 ice creams. But what kind of loop is this if I say I want to eat 6 ice creams? So that could be done with a counter loop because I can just count up to 6, yeah? So that's why sometimes it's usually as a result of some sort of computation. So maybe whilst I eat, until I eat total scoops, I don't know, 20. Okay, and then each time I might have a different level of scoops. So let's say in scoops, because I want to keep track of how many scoops I'm having. And then my while loop, this is always a bad idea to freestyle. Let's see how bad of an idea this is. Freestyle! Sorry in advance. Okay, so then let's do our while loop. Let's do our control variable. Initialize it. And it's going to be the sum of all my scoops. I'm going to say it's 0 to start with. Yep. Okay. My comparison is going to be whilst the sum is less, that's more than, whilst the sum is less than or equal to 20, I will keep eating ice cream. Otherwise, I might stop. Maybe. Okay, so let's do it. Let's prompt the user to ask them how many ice cream scoops did you eat just now? Okay. Excellent. Okay. And then we'll scan in how many scoops this person has had. It's not me. This question is purely fictional. Don't forget to write the and scoops. Okay. And now we're going to pop it into the sum. So sum is equal to, and you'll notice I'm going to do it again because I want the total, the whole total each time that I go through the loop. So sum is equal to sum plus scoops. Okay, that's increasing for me. Okay, what else do I need to do? You notice that this is actually how I also control my variable as well. So this was an updating of the control in this case, and here was my test. Okay, excellent. So what do we think? Do we think that something is going to happen now? And let's at the end when we come out, print out that you've eaten too much ice cream. Have a break. All right. Should we try it? Let's try it. Okay. DCC while condition condition. It compiled, always a good first step. Let's see what it does. Okay, how many scoops? I ate 3 scoops. How many scoops? I ate 2 scoops. How many scoops? I ate 3 scoops. 2 scoops, 1 scoop, 3 scoops, 2 scoops, 1 scoop. I'm not adding them up. So, oh, you've eaten too much ice cream. So, at some point, what did it reach? 5 plus 5, 10, 11, 14, 16, 17, 20, 24 scoops. So I even went a little bit over because my sum became, once the sum became more, then it was time to stop. Okay. So, I don't think so. I think I could do 20 ice cream scoops. Yeah, I think I'd prepare. I wouldn't eat the whole day. I'd get in there, it'd be a really hot day. I can see it now. I feel it. It's good. Ice cream, good. Okay. I like that someone suggested eat Pringles instead. Probably a good idea as well. You can have a new line there, or you don't have to. It's up to you. I do think it looks quite hideous without it, so maybe a new line would be good. And that's not healthy. It's not healthy. You're right. I don't usually have that much ice cream. Okay, fantastic. Okay, so that's a third different way to run your while loop. Let's look at something different now. Okay, what happens if you put a while loop inside a while loop? Someone's calling me pathetic with 20. What happens if you do a while loop inside a while loop? Oh, someone said, actually, good question. I'm just quickly going to answer it. What makes this loop different to a count loop? This is an excellent question. If you could see that I was doing that conditional loop based on a result of some sort of calculation, okay? Whereas a count loop, it's a straight up 1, 2, 3, 4, 5, so on and so forth, okay? Whereas this one is based on a result of some sort of computation, I will stop. So I have to do something to compute something. Okay, so if we put a loop inside a loop, I love it. There's Mr. Loop, I come to loop you. That's made me laugh too much than it should. Okay, so each time the loop runs, it runs the other loop. The inside loop ends up running a lot of times. Think of a clock. I don't even know who uses analog clocks anymore, but if you think of your analog clock, the minute hand goes through 60 times before the hour hand moves once. It's the same with your while loops. The inside while will go many times, okay, until your outside while ticks 1, okay? And the best way to see it is to be able to print out a grid. So guess what? I'm about to make you print out a grid of numbers. So what we're going to do here is we're going to print out 1, 2, 3, 4, 5, next line 1, 2, 3, 4, 5, next line 1, 2, 3, 4, 5, and next line 1, 2, 3, 4, 5. So excellent. Let's break down the problem and then we can try and solve it. Okay. So let me go back to the code and print grid. Okay, so my problem is print out a grid of numbers, and basically we're printing out a square. Yeah, so it's going up to 5 and then it's going downwards 5 as well. Each row increases by 1, the numbers increase by 1, and then we go back to 1 when we start the next row. Oh, someone's like 2D arrays. Calm down, not yet. But yes, this will be a good understanding. If you understand this well, you will understand how to do 2D arrays as well, because it operates in a similar way. Okay, let's have a look. What can you do? We know how to print out one row of numbers, don't we? We've just done while loops. How would we print out one row of numbers? Yes, we can. Kritika, absolutely. We can have different types of loops inside other different types of loops. We absolutely, and often we would have something like that. We're making a digital clock, kind of. Just that counts to 5, which is the time that this lecture finishes, incidentally. It's the time that you get to start your Friday night. Okay, so I reckon let's do let's do. Don't worry about a 2D array, okay? Don't worry about it. You'll find out about it next week. It doesn't matter now. You don't need to know what it is. But understanding a while inside a while, it'll make more sense next week when we do the next thing. Oh, look, I've started coding without actually doing anything that I need to start coding. Okay, let's include my standard stdio.h and then int main void, and I'll return 0. Okay, we can print out one row, 1, 2, 3, 4, 5, yeah? We know how to loop, so how would we print out without doing printf 1, 2, 3, 4, 5? How would we do it? What do we reckon? What do you reckon? I'll wait for comments in the chat. Yep, count loop to 5. Excellent. Let's do it. Let's do that to start with. So we'll do a count loop to 5. Okay. Now. Okay, you've seen me struggle with greater than and less than. Now you'll see me struggle with rows and columns a lot. Okay. I realize columns are the things that stand up, so they're the ones that go vertical. Which one's on the inside? Which one's on the outside? I hate rows and columns, honestly. Okay, I'm going to keep track of rows and columns, or I could just keep track of going horizontal and vertical at this stage. I'm going to say it's row. I hope it's a row. Okay, I'm going to start counting at 0. And what will we do? I'm going to have, this is my control variable and initialize variable. Okay, I've initialized it. Done. First step, done. Next is we open our while loop. Okay, so I'm going to say, we've said in there, so whilst row is less than 5. So whilst row is less than 5, okay, you'll notice I'm not changing the 5 for now into hash define because we're going to do something else after this to make it more complex. What I want to do is I'm going to want to open another loop. Okay. And this loop is going to be a column loop because I also, no, you know what? Let's just print one thing. Let's print one row. We're going to do one row. Okay. While row is less than 5, I want to printf a number. And you'll notice I've put a space behind it. And that's because in this grid, when we're printing out 1, 2, 3, 4, 5, I shouldn't have the commas. I have spaces behind the numbers, which is why I've put a space behind that %d. So I'm going to put a space behind it, and I'm going to put the row number as the thing to print out. Okay, and then what do we need to do in here? What is the last thing we need to do inside our while loop? Last thing we need to do so that we don't create an infinite loop. Yep. Excellent. Let's update it out. So we're going to row plus plus, or row is equal to row plus 1, which adds one more in. Okay, so let's see what this prints out. Okay, we're going to save this and let's run it. Okay, great. Okay, we have something, but it says 0, 1, 2, 3, 4. Okay, so that's a little bit of a problem. So well done. You've already solved it in the chat. My goodness, everyone is so fast. So because I want to start printing from 1, what I'm going to do is I'm going to start counting at 1. And this is to show you that sometimes I'm going to want to start counting at 1, not at 0. So whilst usually we start counting at 0, there are cases when we can start counting at 1, depending what we need to do. What that also means is that up here it has to be less than or equal to 5, because I also want to print out the 5 as well. And at the end, when I come out of this while loop, what else do I want to do? So right now it's just sitting there. I mean, even if it's sitting there, so you tell me what we need to do whilst I run it again to make sure it's working. and print out the grid. Now it's printing 1, 2, 3, 4, 5. So it's printing one perfect row. And someone's saying row is less than 6. Okay, you can have rows less than 6, but it's not very good practice because in terms of style, where has that 6 come from? Why does it need to be a 6? Whereas the 5 still makes it a bit obvious that you're doing it 5 times. It's just equal to 5. Okay, great. Okay, so we want to now, we've got our 1, 2, 3, 4, 5. We've got our first row. So now we want to go to the next. Yeah, so we want to put a new line. Where do you think we would put a new line for now? Would we put it inside my while loop or would we put it outside the while loop? Where do you reckon we would do it? Inside the while loop or outside the while loop? What do we reckon? Outside? Yeah, lots of people think outside. I think that's a great idea. If you put it inside the while loop, what you'll get is something that looks like this. You'll get 1, then you'll get a new line, you get 2, and then so on and so forth. You get 3, 4, 5. So if you do it inside, what you'll get is this. Because it's going to be included in your while loop, okay? So it's going to be included as part of the while loop, which means that the new line will happen 5 times as well. And what you'll get is you'll get 1, 2, 3, 4, 5 each on a new line. So we definitely don't want that. We really want to move that outside of our loop, okay? Because we want it to happen after we've increased. We only want the new line to happen once every sort of 5 lots of times. Okay. So let's paste it outside and let's make sure that it's all working. So I'll save it and let's quickly run it again to make sure that it's all doing what we want it to do. Okay, and so now it's printing it perfectly 1, 2, 3, 4, 5. Okay, and it's moving to a new line. So now how do we make it go 1, 2, 3, 4, 5, new line, 1, 2, 3, 4, 5, new line, 1, 2, 3, 4, 5. Okay. So the way we do that is that we want to have another while loop inside our loop. So we want to have an inside and an outside, okay? So we want to now have a column as well. Okay. Okay, I'm going to do a while loop in here and I'm going to call it a column, and the column has to also be our 5. Okay, now what do you think is missing for me now? And I'm going to fill this out in a second. So I've got this column variable. I haven't given it. Where should I declare it? Where should I declare it? Outside here, outside the while loops, or should I declare it over here? Where should I do it? Where should I declare the column? Here? Line 30 or line 32? What do you reckon? I think there's a slight delay on the, yeah. Yeah, lots of people are saying line 30. Okay, some people are saying line 32. Okay, if I declare it here, okay, int column, and I'll start it at 1 as well, okay. What's going to happen here is it's now sitting, if you remember when we were saying, okay, if I want, no, I'm going to show you what happens if I do it on line 30, okay? And I think by that, you should have done it on line 32. But anyway, well, let's have a look. Okay, so then inside here, I'm going to do my printf to print it out. %d, and I'll print out the column. Okay, then what I'll do is I'll increase the column, okay, to update my control variable. All right, excellent. And then what I'll do is I'll just delete that for now. Okay, so what I have is, okay, so I've got my column here, and should we do increase the row in here because this is the row 1? Okay, there's a few mistakes in this piece of code, okay? It's going to print out a dog's breakfast. I'm warning you. It's not going to work well, okay? But I want you to see these are common mistakes that you make with while loops. So I want you to see what it looks like when it's doing this. Okay, so right now it's printed out 1, 2, 3, 4, 5, and then it printed an enter, and then it stopped. Okay, so why do we think it did that? Thoughts, ideas, suggestions? Yes, lots of people are saying why you should do it on line 32. So what happens here is you're going through it. Row has to be less than or equal to 5. Column's less than 5. Great. So I'll print out the column. I'll do a space here as well. Okay, I've printed it out. I've increased it. So what happens? Let me do it for you so I'm going to write it down so you can see exactly what happens. Okay, row is equal to 1 here and column is equal to 1 here. So is 1 less than or equal to 5? Yes, it is. I'm going to go in here. Is 1 less than or equal to 5? Yes, it is. So that means I'm going to go in here. It says print out the column. It's right now 1. So I've printed it out. And then my column is now equal to 2 because 1 plus 1 is 2. Excellent. So I'm going to go back to the first while loop because that's the while loop I'm in. And I'm going to test, is 2 less than or equal to 5? Yes, it is. Okay, I'm going to go in here. I'm going to print out 2 and my column is now going to be equal to 3. Okay, then I'll do it again and again and again until it's going to be, is 5 less than or equal to 5? Yes, it is. So I'm going to print out the 5 and my column is going to be 5 plus 1, which is 6. So then when I go back to my column and check the 6, it's now not going to be true. So I'm going to exit out. And I'm going to say, okay, row is equal to row plus 1, which is 1 plus 1 is equal to 2. I'm going to go in here and I'm going to say, okay, is 2 less than or equal to 5? Yes, it is. So I'm going to go in here again. But what has happened? What have we forgotten to do? Okay, so I'm in here now. 2 is less than 5. Success. But what am I checking in here? What's my column equal to at this point in time? What's my COL? That's right. Column is still 6. So it's going to say 6 less than or equal to 5? No, it's not. So I'm going to go here and increase it again and do it again and again. So we need to be able to reset the column each time. Okay. And the way we reset the column each time is that the column can't go outside your big loop. It has to go close to where you're going to use it. So you're going to use it with this while loop, then that's where it's going to go. It's going to, because I want it to reset each time I run the inner loop. And that's what I'm doing here. Okay, so that means that we are now resetting it to 1 each time. So it's going to print it out each time. Okay, let's see what's wrong now because it's still not completely correct. I'll be honest with you. I won't lie to you. It's still not correct. So let's see what it does. Compile and run it, and madness. Okay, I mean not madness. It could have been expected. In fact, it was expected. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then a lovely new line to finish up what we're doing. So let's do it. What is going wrong here now? What do you reckon? What do you reckon is my problem now? Thoughts, ideas, suggestions? New line, yes, yes, yes. What's happening with my new line? Yes, yep, new line at the end of the row loop. Excellent. So I should really be resetting my new line every time I increase my row as well, okay? So I will print a new line, then I'll increase my row and then move on my merry way, okay? So I'll print it out, let's save it, and let's try and run it again. Okay, let's compile and let's run. And we have the perfect grid. Okay, so we have our perfect square now. Okay, fantastic. How can we make this a little bit harder? Because, well, why not? Okay, so how are we going to make it harder? Let's see that we want to know this size of the square. We want to be able to actually input in from the user. So it's not always 5, it's whatever the user says it is. Okay, so let's try that. Let's do that. Okay, let's do a variable size. We're going to make it, no, I'm about to, and I'll prompt the user to ask them what they want it to be. Okay, excellent. What size grid? And we'll scan it in. Okay, and so now that we've scanned it in, and I've made a mistake, don't forget the ampersand, very important. So now instead of comparing it to the 5, what we're going to do is we're going to be always comparing it to whatever the size is, because we want to be printing it based on the size that the user wants. So that means that now I'm able to do a grid of any size, really. So let's try and compile it, and then we'll run it, and it's going to ask us, let's do a grid of 8, and it's printed out 8 by 8. And if I run it and I'll say grid of 10, it'll print out a grid of 10, and so on and so forth. Okay, so that was a way to print out a grid. Okay, so what happens now, and we might not finish the pyramid, but let's see how far we can get. Okay, what happens now if we need to do a pyramid, not a perfect square? And the square is probably the easiest thing to print out with a while and a while. You don't really have to do a lot of thinking because it's 1 for 1. But what if you want to print out a grid of numbers that looks like this? What could you do then? Okay, so your while in a while is going to look a little bit different. So usually I like to set these problems out by just thinking what the row and the column and the number of rows looks like, because sometimes it helps you to visualize it. So here I'm in row 1 and I'm in column 1, and is everyone still with me, or have I lost people? How's the situation? Let me see the voting. People are still saying it's just right. A few people have said too slow. Very good. Okay. Okay. All right. All right. Should we go back? Let's, instead of doing the pyramid, let's go back, because I think we need to do a little bit. There's some questions still about the grid. What are the questions for the grid? Pop them in the chat, please. Tell me what was not clear with the grid. Grid. Yeah, a few good suggestions for the pyramid. Absolutely. We can play around with this code to print out a grid instead, because you're really printing out to the number of rows. Yeah, Bill's got it. Number of columns is, yeah. Okay, so what was not, tell me what was the grid okay? Could you please pop in the chat if it was okay, or if you wanted to do something again? If you wanted to go over anything off the grid. Okay, a few people saying okay, yeah. Okay, fine, everyone, okay, great, okay. All right, well, let's look at the pyramid then if everyone's okay. Okay, so we've got row is 1, column is 1, and then the number of rows, how nice, is also 1. Here we're in row, there's 2 rows. There we're in the second column, and the number of rows is 2. Oh, this is working out nicely, isn't it? Then we have 3 rows, 3 columns, and the number of rows is 3 as well. Okay, great. Here we have 4 rows. Yep, 4 columns, and we have the number of rows is 4. So always the number of columns is equal to the number of rows, isn't it? Okay, let's have a look at what we can do to print this out. All right, should we take some of the code from our grid? Let's take all the code from our grid. I'm not going to do the size, I'm just going to do this bit here, and then we can play around with it for like 2 minutes. Yay. Copy. All right, fantastic. Okay, so this prints out the perfect grid for us. And now what we want to do is we want to print out a half a grid. Okay, so what do you reckon? And a few of you have already really suggested it in our chat, in that we are printing out something different here. So the rows here is still, let's say we're going to go to 5, okay? We're going to go to 5 rows. But the number of columns that we're printing is different now, isn't it? So each time we print out, the number of columns is equal to the number of rows that are there, isn't it? And a few of you have suggested that in the chat. So what about if here we say that the row has to be, the column here has to be less than the row, less than or equal to the row. We're going to print out that number. What do you think? Do you think this might give us something? Shall we try it out? Let's try it out. Struggle Town. Here we go. Nope. I'll get it. Here we go. Oh, I've got an extra bracket on line 37. This is what happens when you copy and paste. All right, let's run it again. Let's try it again. Compile. And run. And I ran the wrong thing. Hope no one noticed that. I ran the grid. Let's clear it. Let's compile it again. And now I'm going to run it. Okay. Pyramid is the name of the game that I want to run. First time? How amazing. How is this possible? It's because we really had all the code, and all we had to do is control how many columns are being printed out here. And it was when you're in row 2, you only print out 1, 2. And when you're in row 3, you only print out 1, 2, 3. And when you're in row 4, you print out 1, 2, 3, 4. So your column size is always equal to whatever the size is of your row. And we can do the same thing, is that we can take the input from the user as well if we wanted to. So we can actually do this here as well. So we can, let's copy that as well into our pyramid. And then we can use that as well if we wanted to. Okay, so then here, instead of this, we can just say until it's equal to size. And then we can control how big it's going to be. So then if we run it, and let's say I want to print 7, then it's going to print me a pyramid of 7. Oh goodness, Pascal's pyramid. You don't want to do that. I promise you, you don't want to do that. I mean, unless your weekend is pretty empty, then you might want to do that. Yeah. Oh, it is. It is more of a right angle triangle. Thank you. Absolutely, it is. Yes, the perfect right angle, 90-degree triangle. You won't get any nicer than this. Well done. All right, we're going to finish there for the Friday afternoon. I hope that you all had fun and kept up. If you have any feedback, please. Oh, someone really wants me to crash the computer, I can see. 99. Well, you know what? Why not? Because we're about to finish. Here we go. Let me crash. Oh, I didn't mean to do that. Let me crash for you. Well, maybe. We'll see. Crash. It's doing well. It's doing well. It's doing well. It hasn't crashed yet. It hasn't crashed. We can crash it for the weekend. Oh, it's all happening. It's still going. It's making me dizzy. Will it ever stop? Will we ever get to go and have a weekend? It will. It will stop. I promise. Thank you, everyone. And if you have any feedback, please pop your feedback. No, it's still going. Oh, here we go. No, it was just having a little pause. It was having a moment. Leave me some feedback, please. Would love that. And have a wonderful weekend. We'll try and release assignment 0 for you so that you can get started. And I will look forward to seeing you next week. Don't worry, we're going to do more structs. We're going to look at style, and we're going to look finally at what a function is so I can stop feeling guilty every time I say function. Have a wonderful weekend, everyone. Bye. It's still running, by the way. It hasn't crashed.